Definition: monolithic architecture, a single, unified application where all components, UI, business logic, database access, etc., are tightly coupled and deployed as one unit. Example: early-stage e-commerce websites are simple CRM systems where everything is built into a single, cohesive codebase. Microservices architecture, an architecture style where the application is split into small, independently deployable services. Each service focuses on a specific business capability and communicates with others via APIs or messaging. Example: large-scale applications like Netflix or Uber, where each part of the system, e.g., user management, billing, payment, is broken down into independent services. Development complexity: monolithic architecture, initially simpler to develop since all code is in one place, and communication between modules is direct. Example: a simple blog or a small inventory management system, where developers work in one codebase and all components are tightly integrated. Microservices architecture, more complex due to the need for multiple services, inter-service communication, and handling data across services. Developers must deal with distributed systems and service coordination. Example: Amazon's platform, where different services like product catalog, shipping, and payments are developed separately and must communicate efficiently. Deployment: monolithic architecture, a single unit for deployment. All components are bundled and deployed together as one unit. Example: a traditional monolithic ERP system, where all modules, inventory, accounting, HR, are deployed together as one application. Microservices architecture, multiple independent deployments, each service having its own life cycle. Services are deployed individually. Example: Uber's platform, where ride management, user services, and payments are all deployed as separate services that scale independently. Scaling: monolithic architecture, difficult to scale individual components. Scaling the application requires scaling the entire monolithic app, even if only one component needs more resources. Example: a small e-commerce site that struggles to handle increased traffic during a sale because the entire system must be scaled together. Microservices architecture, services can be scaled independently based on their resource requirements. For example, the payment service can be scaled more than the user registration service if required. Example: Netflix scales its video streaming service separately from its user account services to handle peak traffic. Performance: monolithic architecture, generally faster for smaller applications since there's no overhead from inter-service communication, and all components interact directly in the same memory space. Example: a small inventory management system that does not require complex inter-component communication. Microservices architecture can introduce overhead from inter-service communication, like HTTP calls or message queues. However, this can be mitigated with optimizations like asynchronous messaging or internal caching. Example: Spotify's music streaming system, where microservices handle different tasks like searching, recommendations, and playlist management, all communicating over APIs. Fault tolerance: monolithic architecture, a failure in one part of the application can affect the entire system, as all components are tightly coupled. Example: if the inventory module of a monolithic e-commerce application crashes, it might take down the entire site, including the checkout and payment processing systems. Microservices architecture, easier fault tolerance, as failure in one service doesn't affect others. Each service is designed to be resilient, with patterns like circuit breakers or retries. Example: in Amazon's platform, if a recommendation engine fails, users can still browse and check out products, with minimal impact on the overall experience. Development speed: monolithic architecture, faster to develop initially for smaller applications, as there are fewer complexities and everything is in a single codebase. Example: a small startup launching a CRM system can quickly iterate with a monolithic architecture. Microservices architecture, slower to develop, especially when transitioning from monolithic apps, as it requires more coordination between teams and services. Example: Uber, when it scaled from a small monolithic app to a large microservices-based system, faced delays in coordinating multiple service teams. Codebase: monolithic architecture, a large, monolithic codebase that grows over time as the application expands. It can become hard to maintain as the system grows. Example, a monolithic ERP system where all modules, inventory, HR, payroll, are part of the same codebase, making maintenance difficult as the system grows. Microservices architecture, smaller, modular codebases for each service, making it easier to manage and maintain over time. Example, in Netflix, the codebase for managing user preferences is separate from the codebase for managing video streaming, making it easier to maintain and update each service independently. Testing monolithic architecture, easier to test initially, as all components are part of the same codebase. Unit and integration tests are simpler because everything is in one place. Example, a simple blog platform where all functionalities, posts, comments, user management, are tightly integrated, making testing straightforward. Microservices architecture, more complex testing because each service must be tested in isolation and integration. End-to-end testing is also required for workflows that span multiple services. Example, Amazon's complex order management system requires rigorous testing for service interaction, especially for orders, payments, and inventory updates. Technology stack monolithic architecture, limited flexibility in choosing technologies. All components must use the same technology stack, which can become restrictive. Example, a financial software system where all modules use the same database and programming language, making it hard to adopt newer technologies. Microservices architecture, each service can use a different technology stack or language suited for the task, polyglot persistence. This allows teams to choose the best tools for each specific service. Example, Uber uses a mix of technologies, Java, Go, Node, JS, and others, depending on the specific service's requirements. Database management monolithic architecture typically uses a single, centralized database for the entire application, making it easier to manage but potentially causing bottlenecks as the system grows. Example, a small e-commerce site might use a single relational database, e.g., MySQL, to manage all customer, order, and product data. Microservices architecture, each service often has its own database per service pattern, ensuring decoupling and allowing each service to scale independently. Example, Spotify manages its music data, playlists, and user data in separate databases for each service, optimizing performance and scalability. Communication monolithic architecture, communication between components is direct, e.g., method calls, since they all exist within the same codebase. Example, a traditional CRM system with tightly coupled modules like customer management and sales, where all components directly call each other. Microservices architecture uses APIs, e.g., REST, gRPC, or messaging systems, e.g., Kafka, RabbitMQ, for communication between services. Example, Netflix uses APIs for communication between its microservices, such as between the user profile service and the recommendation engine. Deployment frequency monolithic architecture, deployment is less frequent. Any change, even to a small part of the application, requires redeploying the entire system. Example, a monolithic inventory system might be deployed only once a month or after significant updates, requiring downtime for the entire system. Microservices architecture, independent deployments for each microservice, allowing faster release cycles and updates to individual services without impacting the entire system. Example, Uber deploys updates to its ride management system frequently without affecting other parts like payments or driver services. Resilience and recovery monolithic architecture, harder to recover from failures since a failure in one part of the application can take down the whole system. Example, a failure in the checkout module of a monolithic e-commerce application could cause the entire site to go down, affecting both browsing and payment processing. Microservices architecture, easier to recover through redundancy, fault isolation, and resilient design patterns like circuit breakers and retries. Example, in Netflix, if a microservice managing recommendations fails, the system can continue streaming videos, as the failure is isolated. Service independence monolithic architecture, no independence between modules. A change in one module often requires changes in others due to tight coupling. Example, in a monolithic payroll system, changes to the tax module may require updates to the HR and benefits modules. Microservices architecture, highly independent services with clearly defined boundaries. Changes in one service are less likely to affect others. Example, Amazon's order fulfillment system can update the inventory service independently of the payment or shipping services. This format should give